Hi again, this is Xfixium. Welcome to tutorial number 3. In this lesson, I go over how to convert images into data the Sega Master System can use. We'll be covering palettes, tile sets, and tile maps we'll be using in the game. I've left links in the description to download this lesson's source materials. Hope you enjoyed this one. Okay, we're going to start getting our graphics resources together for our game. Miss Pac-Man has 6 stages total. 1, 2, 3, 4, 5, and 6. The 5th one has the same design as the 3rd one, and the 6th one has the same design as the 4th one. The only difference is the palette color. As you can see, the 6th one uses the first stage's palette color. For our purposes, I'm gonna change that and use this hot pink purple combination instead, only because I want it to be a little different. And the other thing is we'll be bringing a 7th stage into the game, a custom one. So let's get started. I am going to export this image data here in my image editor. I'm going to export, and in our projects folder I'm going to create a new folder. We're going to call it resources, and in there I'm going to call this stage 1. So I'm exporting under the ping format, PNG. We'll get stage 2 here. Export that. Stage 3. Stage 4. Finally, stage 7. You may notice that all these stages that I exported have like this purple color going on here for the most part versus what the original stages had. And this is because I want to bring a unique color that we'll use to index later, and I'll show you what that's all about. But the whole general concept is that for certain things in this game, we want it to be on certain indexes, and it has to be a unique color. If I would export everything as it is plus the way that the original map is, when we go to import it, it won't make unique colors because red is already being used here and red is being used here and that sort of thing. And I'll go into more detail about what that means when we go to import into SMS Tile Studio. Next thing we're going to need is the title. This is more than just the title screen. It's the title, it's the option screen, and it also has all the data that we'll be using for cutscenes. So we're going to take that, export that as well. We'll export that as title. Alrighty. And then the last thing we'll need is our sprite data. Sprite data is formatted a little differently when we use the tall sprite option. And you can see that this transparent color is going to be discarded. Goes around all the sprites that we were going to use for this game. The first 4 tiles is going to be for Miss Pac-Man, and they'll be streamed in. And the second set of 4 is going to be for player 2 or Pac-Man himself during the cutscenes, and we'll be streaming those in. It's going to be a hybrid approach of streaming these 8 tiles, and then the rest of it will be done in a more traditional sense where we load all the data at once, and then for each one of these frames of animation we'll be jumping at to these graphics as depending on the direction that an entity is facing. So right, down, left, and up. And we're going to export as sprites. Okay, now that's done. Going to open up here SMS Tile Studio here, and I'm going to create a new palette right off the bat. I'm just going to call this Black BG. What this means is it's a blank palette that we can use within our game. I typically make this. Does it really need to be made? Probably not. You can do other things to clear out the screen using black, but here I'm going to create my own palette for it, and then it's going to be used at some point in time in our game, and it's just black. So another palette needs to be created, and we're going to call this import BG. This will be a generic import palette for our stages, which is the background layer, and we're going to import those colors based off of our resources here. And we're going to take stage 1, and it's going to bring in our palette from that image. Keep in mind that any kind of image that you want to bring in here, make sure that the colors that are in there don't exceed 16 colors total in the entire image, and that it uses a value of 0, 85, 170, or 255 for the RGB value. And we can see that all these do that: 170, 0, 85, 170, 80, 85, 85, 85, sorry, 170, 170, 85, and so on and so forth. So 255, 255, 255, that sort of thing. It has to be one of those 4 values. If it's not, most likely SMS Tile Studio will tell you that it can't import it. Now it may be a valid color for a Game Gear color, and if that happens, this will turn this purplish color and it'll be bold, letting you know that you brought in colors that are valid for the Game Gear, which uses substantially more palette, or has availability of palette colors way broader than the Sega Master System. So we got our import background. Now I'm going to shift these around into an order that has some logic behind it. So I'll move these around. Okay. And now I'm going to explain what each part of these entries means here and how we're going to use them. So close this out. So when we look at the stage, each one of these colors at the end of this palette is going to represent something within the background. So this dark purple color is the border color that's going to be used for the maze. This color here is the inner filled color. This color is what the pellets are going to be. This color here is for the energizer. This color here is for the 1 up, 2 up at the top of the screen. This color here will be this tile right here, which will be what gets drawn over top of a player when they go through a tunnel, and it also represents when a ghost goes and is over top of the tile that will be used for this. They'll slow down as well. This also is a free space tile. That means there's no collision here. The player and entities can move through it freely. And this one is this color over here, will be drawn over top of any sprites, like the entity, as in Pac-Man, Miss Pac-Man, ghosts, the bonus. This will draw over top of all those entities. And all our tiles at the end here will be solid tiles, meaning that entities can't move through them. So that's what these colors will represent, and you'll see what I mean later. So the first thing we're going to do on tile map side is create stage 1 tile map. I'm going to call this main. I like to have a staging area for other elements that I'm going to use, and I'll show you that real quick. So now we're going to import. We're going to import stage 1. As you can see, based on the default palette, it doesn't look the same as our image. Once we pick the import BG, now everything goes the way it's supposed to. Here's the resulting tile set from this image and import. It has 118 tiles total. Since the Sega Master System can flip tiles in the background, we can actually save a little bit of room for other tiles if we take advantage of the tile flipping portion of, or feature of the tile set. So, or for a tile map. So we're gonna pick flipping options both, and then that will reduce it to 99 tiles. I'm gonna hit OK, and this will be our stage setup here. First thing we're gonna do is we're gonna set the offset to this. By default, if we look at the map, you can see all the tile IDs here, much like previous video where we discuss what these values mean for a tile map. You can see that those values are here. So the empty tile is 0, our energizer is 1, our pellets are all 2s. Same thing here. Thing about this is that we are going we're not going to use 0, and where we're going to place these graphics will be in the second half of RAM, or the bottom half, however you want to look at it, because in the first half, starting at 0, we're going to put our sprite graphics in that portion. So it would be this portion that goes into the top half of VRAM, and then we're going to put this in the second half of VRAM. So the offset has to start where the second half of VRAM is, and that would be the 256th tile. So we're going to put the offset to that, and as you can see, it updates everything based off of that offset. So I'm going to set that first. And for that portion where I said about staging, I like to stage it because there will be parts where I need tilemap tile data. For instance, in this game, we're going to grab this data and put it in an array, and then that array we're going to use for Devkit SMS's functions to write into VRAM. So typically I will go in here and then just right click and then say export the selected tile IDs into an array, a decimal array, to clipboard, and then I'll paste that into the project, and I'll show you that as we go along. Or we can export it as raw binary. So I mean, there's a bunch of options here that you can use to get the data. It doesn't have to be in one way. So that's typically what I do there, and that's why I stage things here. I can just easily grab them instead of creating them here. I can also create them if I wanted to. I can pick this and go into brush mode and then like draw out each one if I wanted to. Like for instance, game over, but I'm not interested in doing that. So the next step we want to do is grab our actual tile map that we'll use. I'm just going to tile map from selection, and this is just going to be stage 1. You need to do a little setup here. So first I'm going to select this bottom portion, and then with the first tile selected, I'm going to go and fill it with that tile ID. That takes care of that. And then there's some other things that we need to do. So the first, from top to bottom of where the actual maze is, I'm going to set the priority here. And then when I go to priority tool, you can see that this whole section was set to P, which means that it was set to priority. And why do we do this? So the reason why we do this is we want this to draw over top of anything that comes through this tunnel. And in the original arcade, it didn't have this extra space on the sides. The Sega Master System, it's 256 pixels wide, so it's wider than the original resolution of the arcade classic. So we have to compensate a little bit for that. You have to, once they go off the screen, typically what happens is if a player or entity went off the screen, it would just show up over here. And why that is in screen space, in our case, it's a value from 0 to 255 when it comes to the horizontal position, pixel position of any sprite that's drawn on here. So if you go less than 0, it wraps to 255, and it's what they call an overflow, because the max value can only be, or the least amount of value can be 0, and the max value can only be 255. So when you go beyond that, it wraps around from 0 or less than 0 to 255, and then vice versa. If you go beyond 255, it wraps around to 0. And typically, if the map was the same, or the maze was the same size width as the Sega Master System, it would just overflow, and we wouldn't really think too much about it. But here, kind of have to fake that behavior, and we want to hide the entities that come through here. So by putting this as priority, it's set that this tile will draw over any sprite. So we set that priority, but we also, if you look at the tile set and we get in here, I right click it or click it, you can see that the first tile is all zeros. So even though we have the tile set as priority to draw all over the player, if it's the first color, it's considered the transparent color regardless. So if you put zeros there, it won't even draw all over the player or the ghosts or any of the entities, even though we have it set as priority. The only time it will draw over is if it's any other number in the palette other than 0. So that's why we have this one here set to 10. So this will draw over the entities or sprites. Same thing with this one. It will draw over the sprites. The difference between these two is this one is supposed to be a passable tile and this one a solid. The other thing about this tile is we're going to make this tile where when the ghosts are on top of it, they slow down. So that's what we're going to do here. I'm going to first set it to the solid tile. So I'm going to select that tile and then set it to that tile ID. So we have it. I'm going to go over here and do the exact same thing. So I'm going to set it priority and then I'm going to fill it with that color. Okay. Turn on the grid here and invert it. And the last thing that we need to do is set these tiles. So we're going to go to brush and I'm going to grab this one that we want for free space or passable. Same here. So everything that comes through here will be able to pass through here, and then the other thing is it will slow down the ghosts. Okay. And as you can see, when we created from the main portion, that offset stayed the same. So I'm going to go through each one of these tools. Brush is brush tool, where you paint based off whatever you select here. You can also create a brush using select. So if I come in here and right click, I could put a brush as selection, and then when I come up to brush tool, I can paint it here. These are some simple tools to use, and you can clear that brush by clicking that. Selection tool allows you to select things, and then if you right click, it has a bunch of menu options here to do whatever one. So you can make things horizontal, or you can make them vertical, or any other the things that Maxim detailed on SMS Power. Those bits for a tile. A tile, like we said before prior, is a short or an int, however way you want to use it. It's basically 2 bytes per tile, so, and that's where we would set this information. H flip just shows which tiles were flipped horizontally. Vertical or V flip, which tiles were flipped vertically. Our priority, as we just showed, this would be tiles that would be drawn over top of sprites. Our palette, we can either use the background palette or the sprite palette per tile. So you can come here and click if you want to use the sprite palette, or you want to go back, and as we can see under the tile set, this is the sprite palette. It's just the default one, that's why it looks so funky. And then this is the one that we used for our background. So it's pointing, this background is pointing to that background palette, and the sprite one, when I switch over, will point to the sprite one. Type, this is those 3 bits and the tile data that's not used, but we can use them technically. So 3 bits is a value from 0 to 7, or 8 values altogether. And we can set that over here to tile type value. And I guess like one way you could do this, instead of looking for an ID, a tile ID that's greater than the end ones here, if you wanted more flexibility, let's say you don't know what your tile set's going to look like in the end. You don't want to have all the solid tiles at the end. That's too much of a restriction for you, or whatever your use case is. And you have a lot of solid tiles. We could probably just go in and mark them as all the free spaces would be, or all the tiles that you wanted on the tile map to be 0. That means that you can pass them, or you can set them as 1 that you can't. So you can get that data from the tile map, read it in, and do the conditioning based off of that. This allows you to do that. You can also go to tile set and then put it into type mode, and we can set that per tile. So if I set it to 1 here and I want all these solid tiles to be a 1, I could go in here and just click them. When we look at the tile map, all the ones that I set to 1 are now 1 based off of this tile set and the type tool. And all the ones that the player and ghosts and bonus can go through are 0s. We're not going to do it that way. We're just going to put all the tiles at the end, but I figured this is one way to show what the type tool can do. Okay, I think that's everything here. This show tile will either show the indexes that we have for each tile, or it'll IDs, I'm sure is what I meant. The IDs that we have for each one of these tiles, or an index, which means it will count from 0 left to right until we get all the way down to the bottom to our last tile. And we'll use that later. There'll be a situation where we need to figure out what our tile indexes are for slotting out our HUD items at the bottom. There's about 12 slots that we can use, and we'll use this tool to select, and then there's a select or export selected indexes, and we can do that here, and we'll have to reverse it for certain other things as well. So it goes to the clipboard, and we'll use that in code. Okay. So the last thing we need to do to set that up is duplicate this. We're going to call this stage 1, and this will actually hold the colors for stage. So let's go here, and we're going to grab these colors for the palette. I have them conveniently placed over here. So the border for the first stage is the red color, and if I use my dropper tool, we can see that this is 255.00, and then for this pink color for the fill is 255.170.170, and we're going to make those changes. So here's our border color, we're going to go red with it. Here's our fill color, we're going to go and get that pink color. And then the next color is the pellet color, which is white for this stage. The Energizer is also white. And then that portion where we have 1 up, 2 up, that will always be white as well. These other parts will be black. So these are the ones that get drawn over the entities. And the reason why I have separate indexes for certain things on here is because we're going to flash these colors at some point in time. So like, for instance, the Energizer flashes on screen. What's going to happen is when we write code, we're going to flash it from black back to the original color that it is for whatever stage it is, because each stage can have a different color for it, so red, yellow, whatever it may be. So we're going to flash it from whatever its original color is, which is here, which is white, back to black, and then it'll have this effect that it just blinks it by just changing one single byte on the palette. Same thing for this. This is where the 1 up, 2 up, depending on which player is current or players are current. It could be player 1, player 2 might flash, or it might be team mode, so both of them flash. And then these two colors back here, there'll be a moment when the player completes the stage and we want to flash these two colors at the end. So now that we got our setup here, and go over to our stage 1, and I'm going to go over to tile set, and I'm going to switch over to that stage 1 BG, and then that will give us our end result. Now that we have that, we will continue on. We're going to do all the rest of the stages. Then we're going to do the title, and then lastly we're going to do the Metasprite import. So let's get that done. I'm going to start with defining all the palettes that we're going to need for this game. I'm going to just duplicate this. We have 7 stages, so 2, 3, 4, 5, 6, 7. Change the names on them. For stage 2, it's this blue stage here. And the border color is white. So I'm going to set it to white. And then this color, I believe, is the same one as this one here. So the blue color is 0, 170, 255. Palette color is a bright yellow, and again I can double check that with my dropper tool. So it's 255, 255, and 0. And the energizer is the same color, and then of course this stays white for the 1 up, 2 up. Then we'll move on to the next one, which is stage 3. This is probably my favorite color scheme, and we're going to make the border color for this one as white. We're going to give it this orange color here. And then red is the pellet and energizer color. So that takes care of that. For stage 4. We want this orange color that we had before, this one, 255, 170, 85. Is our border color. The fill color is actually straight up blue, so we're going to use that. The pellet color is white. Energizer white. Moving on. Stage 5, we have that over here. The border color for stage 5 is yellow. The fill color is a pink. Looks like 255, 170, 255. So we can find that. I think it's this one here. It is. Then this cyan color looks like the one that's up top of here. 0, 255, 255. So I'll look for that. There it is. And then the energizer would be the same color. Okay. Now we're going to use our own color for the sixth stage. So I'm going to use this. Get the values of that. What that would be for our border color, we look 255, 0, 170. That would be this hot pink color. Then we want the purple color, which is 850255. That's that color. Pellets yellow, so we're gonna use yellow for both of our pellets, and that will be the end of stage 6. And then I know I'm using red for the border for the custom one, the custom stage 7. 170 is the green color, so we'll use that. For the pellets, it is yellow, and then what's different here is the Energizer is not going to match the same color as the pellet. You're going to leave it white, and that should be that. Okay. So we have all that. We need a new palette that we're going to call import sprite, or SPR. I'm going to bring in the colors from the sprite image. And what I'm going to do here is I'm going to reorganize this so that it matches as best as it can the import BG color indexes. Reason why I do that is I typically want it to match, because if I switch certain resources up, I want the best possibility that it's gonna match up the indexes without having to change the actual graphical resource. So that's all I'm doing here, is matching what colors that are that are similar to the import BG I'm going to do here with the sprites. So I'm going to move these around much like the import BG. So I think that's it. And if we look at the import BG, we can see like the first 8 colors or so match up with the sprite. So we have our import SPR, and then I'm going to duplicate that, and I'm going to make that our main sprite palette. The only difference is, instead of having this magenta color, I'm going to make it black. Typically the background color within the SMS background would be the first color of the sprite palette, so I don't want to burn or bleed anybody's eyes while they're going to load up a game in the Sega Master System. I just take everything it has here, which we're going to use for our import, and just when we export it, we're going to use black instead. So okay, that's taken care of. We're going to create a duplicate off of this, and we're going to call this Flash BG. And this is just a copy of our background palette, but we're going to make some changes here. We're going to, of course, make these black. These are the ones that are going to show up on top. This one is the text, so I'm going to leave that white. These will be the Energizer and the pellet color. We don't care about this, because by the time the stage is complete, these should be all gone. That's the whole goal of the game, is to eat all the pellets. And when we flash, we're going to use this to flash the maze at the end a bunch of times before it goes on to the next stage. So we don't really care about these. We're just going to be black for those. What we do care about is this fill color. We're going to make it black when it flashes, and then the border color will be white when it flashes. So that's all this does. And to some degree, we can just change these two in code, but I just like making one general call instead of adding more lines of code. I would have to go to each one of these indexes, and instead of doing that, I just have one line where Devkit SMS will just replace the entire palette. It's not going to kill anything. Alright, and the last one we need to do is I believe the last one is the title. Again, these are going to be background tiles, so I'm going to put BG for this palette. And I'm going to import that title. And again, the same way that we did with the import sprite, where we're trying to match up as many colors between the background and then sprite palettes. I'm going to do the same thing here. There's very similar colors between all of them. So I'm just going to do it the same way. And that's all it takes. So that's done for all the palettes that we're going to need in the game. And now we can focus on the tile maps again and get those done. So I'm just going to create a duplicate of this. Let's do it. Let's do it 4 more times. I'm going to change this one to stage 2. This one's going to be stage 3. Stage 4. And stage 7. Those are the ones with the unique design layouts. 5 and 6 are the same as 3 and 4, but with just a change to the palette. So there's no design change there. But we will make an entry here just so we can take a look at it for reference. So for this first one, you want to bring in stage 2 design. Again, we're going to pick both and we hit OK. For this one, we're going to bring in stage 3, of course. We'll reduce our tiles and move on. Stage 4. And lastly, stage 7. All the graphics for this game will be available as part of the project, so you don't technically need a graphics editor. They'll be supplied for you, and then you can set up any way you want. You can go through bitmap tiles, or if you choose, you can use SMS Tile Studio. That will be part of the package too. Looks like I didn't name one of these the right way. But that's stage 3 for sure. Okay. So for stage 2, we're going to do what we did with stage 1, where we select our actual game tile map that we're going to use in game. And we're going to make a tile map from the selection and get rid of the main portion of it, and we're going to do the same thing through all of them. Looks like I didn't update this design. Let me update that real quick. So I don't want this right up against that. It's going to make a brush and go in and paint this over that, and then clear the brush, select the tile ID over here, and just get rid of these little parts here. Again, I just want this to be a little separated. Okay, now I'm ready to export this. So I'm going to pick this and tile map from selection, and then again, same thing, get rid of the main portion. Okay, now I'm going to go through each one of these, get rid of the bottom portion, make that the first tile. By default, it's selected when I change tile maps. The other thing is when we duplicate, we also save that offset so I don't forget it, which I forget it quite often. Okay, that takes care of that. Then we go into stage 2 and set up our solid and priority. So I'm going to set up the priority here and then set the tile ID. Same thing with this. Set priority and set the tile ID. And then I'm going to go in and set those areas with the brush tool. One in the grid. There we go. And set up right to the edge and right before they enter. So they'll slow down as they're going into this section. Okay, I believe that's everything for that. And we're just gonna do the same thing for the rest of the stages. Nothing too exciting. Again, we can always check if that priority was set by going to the priority tool. That's set, and then finally our bonus stage or custom stage that we made for the holidays. And there we go. All right. Now we'll go and set these to their respective palettes. Okay. And then for reference, all I'm going to do is take stage 3 here, and I'm going to duplicate stage 3. I'm going to call this stage 4. So I want to make sure everything looks okay, or if I make changes in the future. I'm sorry, I meant that to be stage 5. I'm really paying attention here. Stage 5. And stage 4 will be duplicated as stage 6. We'll use stage 6 palette, and that should be updated. There we go. So stage 6, stage 7, let's take a look just to make sure they're okay. Stage 5 looks decent. 4, 3, 2, and 1. And I think they're all set and ready to go. Moving on to a new tile map, and we're going to call this one title. And we're going to bring in our, title main, because it's going to be a staging. I'm going to import that tile map, and I'm going to pick our tile background palette, and we have 153 tiles, and I'll probably go down only 2, and it does. Only 151. Didn't get too much savings there, but it is what it is. Now for this particular graphic or tile set, I need it to be at a certain position tile-wise. You remember with the stage it was 256. We're going to reuse some of those tiles from the stage tile set, or these ones in particular. So the one that all the graphics that show the high score I put closer to the top, or at the top for the most part, strategically, because I know that I'm going to use them later. Not so much these other portions like the pellets and the energizer. I put those there anyway. So we're going to grab all these tiles and put them at 256 like we normally would, but only these tiles that have to do with the high score, because we're going to still show the high score on the title, so we need that. And instead, after those tiles, we're going to put all these tiles from our tile set after those numeric ones, and for the ones for the actual score. So that means we need to put it whatever those amount of tiles are, which I don't know off the top of my head. I think there might be 23 tiles or something like that. You add 23 to 256, I believe, and we get 279. So that's what we're going to put here. So now all the tile IDs, when we go to look at them, they'll start at 279, and our first tile will start at 279. That's all we did here. And again, I put this here because I want to select certain things. Like later when we put together the act tiles, I'll use, again, the same stuff that I used before, like exporting the tile IDs to the clipboard. And you'll see that in action when we actually go to program this. The main thing I really want from here is the title screen itself. And I'm going to export as a tile map. I'm just going to get rid of main. And this is going to be title. And then to make sure that we are filling the entire screen with this, I have it that, well, we can look at it and say, all right, is it 32 columns by 24 rows? If it is, that means it's going to fill a standard Sega Master System screen, which means 256 or 32 columns wide, or 109, well, by 192 pixels high, or 24 rows. If you take 192 and divide it by 8, it gives you 24. And if you take 256 and divide that by 8, it gives you 32. And that's where these numbers come from. We call those columns. They're the width of the screen, and then rows, which is the height of the screen. And we divide it by 8 because each one of the tiles on the screen are 8 by 8 pixels, and those are the reasons for all that. So hopefully that makes sense. And then when we go to tile main, and what we want to do is grab our options screen, which we're going to do here, and we're going to create a tile map from that, and we're going to call that title options. And we're not going to use the whole thing, but we're going to use it for reference, because if it's the same size as the screen will be, which is 32 by 24 here in tiles, then when I go to take portions of this, I know where it's going to need to be drawn. Devkit SMS allows for certain functions to send data to the VRAM. So when it's the title screen, and then when the player presses a button, it's going to wipe out this portion and give the options portion of the screen to the player. So this will be its own tile map that we're going to use. And again, I just do it this way because at the end here, that will show me the position here what it would be in screen space, or the space that the VRAM can draw. So here it's telling me the tile X would be 3, so from 0, the horizontal tile for where this sits is at tile 3, and then from 0, the vertical position where this sits is at tile Y 16. So it's saying 3 tiles to the right and then 16 tiles down. When it comes to the vertical calculation, it will increase because this is considered 0, 0 at this point. So think of it as a cross that goes through an old geometry. This is 0, 0. If we keep going down, it will add, and if we keep going right, it will add. As we go towards the left, we subtract, so we're at 0, 0. If we go up, we go towards 0, 0. So that's how the coordinates work in this. And as you see, when I go over with my mouse in certain parts of this, it will actually show down here where we are positioning wise in a tiled fashion. So, and then it will give you the actual tile, and it will give you what that would be in pixels. So position X is 24 pixels in, but also 3 tiles in. So if you take 24 divided by 8, it's going to give you 3. So same thing with this. I'm going to take a portion of this. I'm not going to take the entire screen, but I'm going to take a portion of this, and then that's what I'll use to draw over top what was originally there, which would be this. And Devkit SMS gives us some nice handy dandy functions to do that. It's very convenient. Okay, so I think that's everything there that we need for the time being. I don't need to do anything special here. Last portion of this, we're going to bring in our metatile, our metasprites, sorry. Our metasprite data. Metasprite is just a collection of sprites. As we went all over before, sprite can be 8x8 pixel tiles, or it can be 8x16 pixel tiles, depending on the mode that you have set for your graphics, your sprites, which it's either normal or what Devkit SMS calls tall sprite mode. For this game, we're going to use tall sprite mode. So new metasprite here. So we're going to start, and remember I was talking about that graph, the old geometry, if you recall it, or if you're currently going through it. We're just interested in this half for the most part. Well, when it comes to our background, we're interested in this portion that goes down and over. With our sprites, we can actually go into negatives. So sprites, we can set the offset, and I do this with TMNT. You don't have to, based on how your animation goes, you may want the offset to be a little different. And this particular case, we're not really worried about making animations. Typically, that's what this is used for, to make the animations for sprites and offset it to different areas and stuff like that, especially for more complex sprites like in TMNT. In this situation, we just want the data. We're not looking to make any animations out of it, or we just want to split up our sheet into a way that we're going to use it in the game. So I'm going to start this off by calling this meta sprite bonus, and we're going to import our sprites here. As you can see, we need to pick our import sprite so we can get those colors set correctly. And then I'm going to go into tall sprite mode. And in this case, it doesn't really matter if it's normal or tall sprite, but I think it's less confusing if I use tall sprite for this. So for a bonus, we're going to pick all the graphics that we can use for a bonus, and it's in a format where the fruits are progressively getting more value out of it, or more points. So, we start with the cherry, then the point value. It's marker for the bottom screen, meaning that it's off screen, we can't see it, but we'll be able to see where its general position is, horizontally at least. And then for the marker up top, it does the same thing, where it generally gives a horizontal position of where something off screen at the top may be. So that's all we need for this graphic. We're going to grab all this here, and then I'm going to say add. And then I'll add our sheet here. That's transparent color there. And again, when it goes into the game, it will be using black for that. So we got our bonus. Then we need, I'm going to duplicate. And I'm going to go and create another one called cut scene. And we're going to import some cutscene graphics that aren't a general use, like the stuff that's on the title background, because all that stuff's background tiles. These will be the things I'll be animating. Okay, and then we just add that. Duplicate again. We're going to make another one called player. Reason why we're splitting these up in the way that we do, it just makes it easier for me to use them later. If I just use this whole sheet by itself, one, I'm not even sure if it would fit in a bank by itself. It may. I'm not sure. But two, if I have them separated and I go to get the certain frame out of this data later, I know that it starts at 0 versus if I would keep the whole sheet together and then go into the resource. And I'll show you what that means later, because all these tiles here in particular, they get streamed in from the ROM data at the end. So again, I'll show you what that means, but it's a lot more manageable when I have them in this small tiny resource than if I would just keep the incomplete sheet and use it that way. So I'm going to add that. And then the final one we need to do here, and I'm going to duplicate, is the biggest one. I'm just going to put sprite down. And we're going to go again into tall mode. And I'm going to grab from the very top and then get it right about here. Actually, I don't need to include these ones if I want to, but I'll just put them as a default, because these will actually be replaced. I have two bonuses come into the stage when the player eats 70 pellets and when the player eats 170 pellets. And when you go through the first 7 stages, they're in order. So, they would go cherry, strawberry, apricot, or peach, or whatever you want to call it, orange, pretzel, apple, pear, and then the banana. But after that, it becomes random, and the value is placed in this table that has 32 different values that it could be at any point in time. So the first bonus fruit that's randomized could be whatever, and then the second fruit, so it doesn't match the first time and the second time, they're different. So I have one set to load, and then another set that I load when the stage first starts. I don't want to load this while the game's running, because it will spike the processing when I go to stream the tiles in, and I'd rather not do that. So I figure out the fruits, or the bonuses I should say, at stage load, and I load those graphics that we just have over here. That's a bonus. I load whatever the randomizer comes up with, I load those tiles into VRAM at that point. So that's what I explained here. The rest of this stuff is just the ghosts and their points value, and that's it. So, and you can see the markers that's associated with them. Add that, hit OK, and that's everything. That's everything for this game loaded. And I could save it at this point at least. So we're going to call this you can save it as the SMS Tile Studio project file format, or you can save it as JSON. This typically would be okay, but I noticed that GitHub doesn't really like that extension too much, so sometimes I just save it as JSON, and JSON is really what it is in file format, so it's just serialized JSON. Okay, I'm going to pick that, I'm going to hit save, and that will save this entire project. If you need to make any changes later, which during development of this I made quite a lot of changes just so I can get things more optimized on where the tile positions are and some other things that I didn't really think of later. Like I didn't originally plan on having a different color for the player 2. It was going to be originally just the same colors as Pac-Man, but I just like the idea of having a different color Miss Pac-Man in it. So, and then for team mode and all other stuff, it makes more sense to have it that way as well. I don't want to just bring Pac-Man in. I thought this is a Miss Pac-Man game. Should be Miss Pac-Man. So we're going to export everything now. So I'm going to export as binary into the assets folder that we already created for our project. And as you can see, I'll use the name of whatever we put in here, and then I'll append pal for a palette. And we're just going to go through here and just export each one. I don't have a bulk save for this. I do for tile maps. We're just going to export every single one of these. Okay, that's done. Now we're going to go to the tile map, and we're only interested in any of the designs that are different, and we're not interested in the main. Obviously, you don't want to export that. What we have to do first is export the tile set, so the actual graphic. This over here, we want to export. It only needs one export because we're going to use the same tile set throughout the whole entire game for stages. So I'm just going to back out of that and have stage underscore tiles. That's all we need. I'm going to export that, and then I'm going to actually export the tile map, the actual design, as a binary. So stage 1, stage 2, stage 3, stage 4. We don't have to do for 5 or 6 because those designs are 3 and 4 in actuality. The only thing that changes between these stages is the palette. So that's why we exported those palette entries for 5 and 6. For stage 7, this is a unique design, so we need to export it. So stage 7 gets exported. Then we want to bring our tile map out. So we're going to export that as title. These other ones we don't want to export because all we're going to use is, we're just going to slice up portions of it to overwrite the original title. So we don't need anything else from there. We need to export all our tile sets, or these sheets that are being created for each one of our meta sprites. So export tile set as binary. I'll have bonus tiles, cutscene tiles, and so on and so forth. So I'm going to bring those out. Again, those will be formatted in a way that the Sega Master System understands the tile data to be for a tall sprite. Okay, and I believe that's everything. And you'll see later on when we go to use assets to banks how all the graphics resources are organized and how it creates these banks and what banks are and what bank switching is all about and how important that is when we get to the programming side of this. But for now, I believe that's the end of this tutorial, and I hope you enjoyed it, and I'll see you next time.